So we'll start.
Yes.
Okay, fine. So we have been going across the solar system using our flying school bus. So fortunately, you know who I am. So I am Abhi, and all my friends are there in the bus today also. And we are exploring some facts about exoplanets. We are trying to learn about what are the types of rains, what is the life of an astronaut over the last few weeks. And we are coming all these things together so that we are going to explore a new place, a new planet today. So what did we see before? We saw all the exoplanets, what are the planets doing in the outer solar system or beyond our solar system, what is happening in particularly to one exoplanet called 452b, Kepler 452b. How is it far away? When will we reach us? All these things we were seeing the last time. So there was a breaking news that there are three different rovers or three different orbiters, rovers, and mission is happening in Mars. So we are suddenly asked to turn back and we have to go and see what is happening there. So that's what we are going to see today. And before that, we have visited this place about 6 months back. In the episode 5, where did the Earth's robot go? We were going across all the Mars and we were seeing all the planets, all the places in the Mars surface. We were seeing a lot of places where they have already taken photographs, all the cool things that it has already done. What did the last rover do? All these places we saw. Some of the facts about the places like Murray Buttes, Gale, Hale, Cater, all these things. And before ending that day, on that 6 months back, he also saw something which was very unique, which had a very big opening. There was a lot of delta sedimentation in that place. That place was called as Jezero crater. What is this Jezero crater? It's about uh, 70 kilometers wide, and it's filled with lots and lots of deposits of water. It might harness a lot of microbial life. That's why scientists have thought this might be the right place to go and see, and they are already planning to have missions in the future for this particular one small spot in the Martian surface. This is the Jezero crater. So what is so special about it? We are going to see today. So this is Jezero crater. When seen from the top, this small circle that is around 10.5 kilometers in diameter is the
Good
place.
evening, sir.
Good evening, hi. This 10.5 kilometers is the place where our Perseverance rover has just landed. So it's a small place and this is of very high importance. This yellow circle is very important. So we are going to go there today, and we know that we are going to also find a lot of our things that we have left behind. We have left behind a spacecraft, a telescope, and all these things. So we are going to find all these facts that we have missed some 6 months back. So that's it for the last episode. Today we are going to see what are we going to find in the Mars. So we had the opportunity to have the Mars orbiter and the Perseverance probe to be launched some 7 months back. That is in the month of June. So from June it had traveled all the way up to the Feb 19th. So sorry, Feb 18th. So and it had landed there. So this is a ideal space. So Earth is here.
Did it happen recently?
Yeah, it happened just 3 days back.
Where did it come from?
It came from Earth, Kanama. So from here, this is Earth, and it went all the way to Mars. So from here,
Which country, sir?
it went from it is from Earth. So it is from NASA. Aeronautic Space Administration is managed by America, United States of America. So it's from USA. So from here to here, it went for about 7 months, and it landed there. In that time, had taken a lot of effort. So it had collected a lot of information, and it had collected so much of things in it. So what is inside all this? So there is a rover there. There is a protective shield inside. There is a sky crane. All these things are engineering. So they have engineered, all the scientists have thought through and engineers have thought through to design it in such a way. In 7 months, they will have enough information to work out what is going to happen in the next 2 years. Because Earth and Mars are little far away. So as you see, we will complete 1 year cycle in 365 days. So for Mars, it will take somewhere around 470 to 480 days. So by the time it goes one time, we would have completed at least 1.5 times. So for it to be in the same time, it will take at least 2 years for us to be in the same place. So this is little tough. So that's why scientists always plan 2 years ahead for all Mars missions. So that is why we have sent a spacecraft 7 months ago, and it had reached Mars just 3 days back. And with that, we know what is going to be the surface action. So how does it look? What does it feel like? So I'm going to show you a window, so that might be easy for you to understand. Just give me a second. So this is going to be my internet is a little slow. It's fine. So I will do it now from here, then I'll do it later. So the rover went into the space through a lot of maneuvers. So it had changed all the direction. It had used a lot of gadgets in its surface, and it was able to find the pinpoint. That is just 10 kilometers. It was able to match, and it was able to lower it. So it had used a lot of photographic reference. So it had taken a lot of photos when it was falling down, and as it turned on the cameras, it was able to see, oh, I'm this far away, I'm this close, I'm this distant. All these things it was able to do, and it was able to make that interesting judgment whether it is going in the right direction. And this is the extent of the sky crane. So it had a very booster rockets on the opposite side. So when it fired, it went deep, and it all prevented it from stopping for about exactly at 10-15 meters above. So once it dropped, it had kept the place for some time, and it lowered the wheels, and then it flew away. So all these things that are inside, so the spacecraft has some different kind of instruments. What are these instruments? Okay, scientifically, people, when they are interested to do some experiment, they'll always carry some apparatus. So what they can think as a experimentational learning. So for Mars, to study in Mars, we need to know what are the things that are best suited for living there. So in the future, maybe in some 10, 15, 20 years from now, when people go there, they need to do a lot of activities. So they have made everything into one big rover, and they have attached all the instruments, and they have sent it there. So by the time we go there, say in 2030 or 2035, we will have all the information. So what are these instruments? So there is an oxygen generator. So when you have, what do we breathe to live? What is our inhale and exhale gases?
Oxygen and carbon dioxide.
So what is
Oxygen, sir.
oxygen? Okay, we inhale oxygen. Very good. So what is that we use for burning fire?
Oxygen.
Can I burn oxygen in the vacuum of the space?
No,
Sir, I
sir.
can't understand.
Can oxygen burn in the vacuum of the space? That is, if I go
No,
up,
sir.
in the
No, sir.
No, sir. The amount of oxygen will become less.
yes, so it will easily dissipate. So but there is one place in the entire Martian surface where you can try to experiment it. That is, one is in the North Pole and the other is in the South Pole. That is, you have a lot of H2O, hydrogen dioxide, that is also called as water, and that water you can separate it out from hydrogen and oxygen and create it as separate oxygen. But it is a very existing process that it takes a lot of energy. What they did, scientists thought maybe we should find another source. So what they did, they took carbon dioxide, that is what we exhale out. So every time we breathe, we take oxygen, and when we breathe out, it comes carbon dioxide. So why don't we make oxygen? Because it has one part carbon and two part oxygen. So somehow if you try to separate it out, you can create new oxygen. So they thought, and they started trying some experimentation in Earth. They found it okay, but will it be able to do a lot of things in the Martian surface? Because Mars is entirely made up of carbon dioxide. So the more you try to make oxygen from carbon dioxide, it is very cheap for them. You don't have to waste a lot of money. So that's why they started making this Martian robot. This is a Perseverance rover. So it's about 1,000 kilograms. So it is quite big. It's like a mini baby elephant. So this baby elephant sized robot is going there, and it is doing all the experiments. It is going around. It's also very tall. It's about 7 feet tall. So if you try to stand next to it, like 3 times taller than us. I mean, as a kid. So it will be 1 feet taller than me. So all these things are happening there, and all these instruments like analyzer, instrumentations for finding the surface when you go deep, and how is the ground shaking, is the ground having any water inside, all these equipments are placed there. Also, they have thought through a future mission, that is some in 2026, that is now we are in 2021. So in 5 years from now, there is a plan for an European exploration program where they will pick up some kind of soil samples from Mars, and they will bring it back to Earth by 2027 mid, something like that. So this is a planned mission for which they are calling it as a sample caching system. So they have got some 43 samples to collect, and they are starting to dig. So from day 31, that is 19 days, 20 days from now, they'll start to make holes, and that hole will prepare all the gadgets inside. So with all these things, you need to know what is the power of the machine. So how much power does it consume? What are the ways in which it can work? What does our electricity made up of? How is our
Sir,
electricity?
sir, can you say it again?
How is electricity made in the earth?
Made from many natural resources,
Like,
light,
okay.
water, hydroelectricity.
So I'll explain what it means. So if you have gone
Wind electricity.
if you have gone for vacation, you might have seen some huge dams, water dam. So there is one side there is very full of water. The other side there is flat land. So from inside,
Heat wave, sir.
sorry,
Heat wave.
heat wave. Yeah, you can also create electricity from heat also. Yeah, it is called turbines. Okay. So like that, you have lot of places like dams where they can make electricity, and all these places are there only in the earth, because there is no water in the surface of Mars. There is wind, but we can't go and build a wind turbine, a windmill in the Mars right now. So there is a very big infrastructure or a very big real estate to work on. So what they did, they thought maybe we should think about things very small. So they sent an small nuclear generator that is made up of plutonium 238, and they have kept it there, and it is now powering it. So for any usage, that is around 110 watts of electricity, that is the US standard of electricity. So for India and the other parts of the world, it is 220. Somebody is sending me a message. Yes. Why did you raise your hand? Any question?
No, sir.
Yes, sir.
Yes, sir. Yes, sir. What is your question, sir?
What is the burning gas made of, sir?
Made up of Sava. What is Sa? I didn't understand the question, Karma. What did you say?
What is the burning gases made up of, sir?
Burning gases. You're asking about when we burn something, what are the gases that come out? Is that right? There are many gases that can burn. Oxygen is
Sir,
one.
he's asking what is present in the burning fire, sir.
Burning fire in for Earth, it is mostly made up of oxygen. But there are also other materials that can burn. There is phosphine that can burn, magnesium that can burn, uh, lithium that can burn, uh, vanadium that can burn. There are a lot of
A
elements.
light of carbon dioxide?
Carbon dioxide, it cannot burn. It is how do you say?
Hydrogen, helium?
Hydrogen, helium can burn, but it has to be highly compressed. It has to be highly pressurized so that it can start burning. It is not very active burning, but the one which can easily burn is much easy to burn. For Earth, we can say all these elements, the most easiest gas to burn is oxygen. That was your question. Is it okay? Not okay? Okay. I'll try.
No question, sir.
So all these things are happening. So they are trying to make a lot of energy from plutonium 238 to make all the equipments run with all the battery power. So apart from this, there is also a lot of cameras. So there are around 23 cameras which are taking photographs of all the things that are there in the system. So why do we need it? Why do we have to all have all these things there? Because we are experimenting with a lot of equipments which are brand new. There is a first way in which we are exploring the components that are there in the surface. We are trying to find whether the robot or the rover can move on its own, the autonomous driving system, whether there is any difference in the temperature, is there any sound that is there heard in the surface of Mars. All these things they are trying to recover using a lot of these cameras. And all these devices are made sure that they are working all around the time. That is around for the next minimum, the time period for which it is given is 2 years. So for 2 years it has to continuously run. So all these equipments have to have some power so that they have managed it using a small nuclear reactor. So if you consider this, so what happens if you collected all this information, taken photographs and all these things? So where does it come after that? So it has to be sent back to Earth. How do we send back to Earth when it is this far away? So by the time it has reached there, so we are going ahead of Mars. So when we launched, so Mars and Earth was very close. It was just around um, some 13 million kilometers or something, just less than that, or 10 or 13 million kilometers, I'm not sure. So from here now we have gone cross more than 20 to 30 million kilometers. So with this kind of distance, it takes a little long for the signals to come to Earth. How long do you think it will take?
For what, sir?
For if I say hi to Mars, for the rover to reply back hi, how long will it take?
100 days, sir.
23 million years?
No, it will take somewhere around 20 minutes. So it is like
Okay, sir.
talking to someone who is 20
20
minutes
years, sir.
20 minutes, and now it is 5:50, so I have to send message by 6:10. So it is like that. So it is going in such a way. So for Earth and Mars to have this communication, there has to be some kind of satellites, right? So what do we use? What do they use? They use a Mars Reconnaissance Orbiter that is there from the year 2005. It is going around and around the Mars for all these times. So for the last 15 years, it has been going there, and it is sending out signals to the Mars rover, and it is asking the Mars rover to send back all the photographs so that it can upload it to the data bandwidth, and it will reach Earth in the 20 to 30 minutes time. So every day for about 10 to 11 hours, it will start pointing the satellite antenna towards Earth. It will beam the data. It will collect any data and send it back to the rover in just around 20 minutes. So all these things are happening simultaneously. So it is not very efficient way, because only 10 to 11 hours we will get information. After that time, the rovers will go to sleep, so they have to work on the overtime. So this network is made across using a deep space network that is located at 3 places across the Earth. So one is in California, it is there in the US. The other is in Spain. The other is in Australia. So all these 3 red color satellites are collecting the data for 10 to 11 hours. They are joining them and they are giving it out as a photograph. I'll show you some of the photographs that have come from this exploration. So this is done using an X-band communication. So this is too technical, but if you can compare it, our internet speed is somewhere between 10 to 30 Mbps, but this is happening at around 60 Mbps per second. So that is going far beyond that, and it is much faster. So it is several times faster than our home internet, that is the DSNL internet. So these are the photographs that have come. So this Mars orbiter took photograph of the spacecraft that when it is getting landed. So it takes about a little bit of time. So it will drop and it will go for about say 7 minutes to the surface. So at that time it took a photograph. So it happened on day before yesterday, on 19th of Feb. So as it was going down, there was a downward pointing camera. This was some 30 to 40 meters above the surface. So it took a photograph from that as the crane was lowering the spacecraft. So as soon as it landed, it sent a photograph showing that my tires are very good. I don't have any problem with my tires. So this is the image I'm looking at from my front end camera. And the camera on the bottom looking at the hazard camera, that is what is the terrain looking like. So is it made up of very rocky surface, is it a very flat surface, all these things. It was taken just minutes after landing on that time. So we got all these photographs to explore until now. So these photographs are going to come more and more, and we are going to explore more and more about what is happening there, and we are going to see what all the experiments that are going to do for the next 2 years. So these are the things that we saw today. What is the spacecraft made up of? When was it launched? An overview of the entry, and how is the terrain guidance system working? All the instruments with this overview. Now I'm going to show you something which I need to load up. Just give me a second.
Sir, I have a question.
Yes, sir. Please tell me, sir.
Is Mars a destroyed planet?
Mars is. You're asking as if it is a destroyed planet.
Yes, sir. I heard some people call it a red and destroyed planet.
Destroyed. You cannot say it as a destroyed planet. It is a kind of a. It's a kind of a planet which has long had to be some kind of like
Okay.
so you might be able to see my screen. You can see the screen.
Yes, sir.
Okay.
Yes, sir.
So this is the Mars.
I can see some.
You can see the rover. It is there in 3D. So you can know all about the. So you can see nuclear reactor. Yes, Lakshya, tell me. Lakshya, you have a question?
Sir, on some of the spacecrafts and things that are going to other Mars and from NASA, why do those things are covered in gold?
It is not okay. It is not gold. It is a okay. So it is an isotopic element. So it's a combination of 2-3 elements, but it is not gold. It is made up of bronze nickel and aluminum. So it's a kind of composite element. So it is protecting it from radiation. What is radiation? So we have got so much of radiation on the surface of Mars. Apart from Earth, we have very big atmosphere. So our Earth is protected. So we don't get any ionizing radiation. So we don't have anything to worry about in our skin or on the electronics or anything. But all the Mars rover is made up of sensitive electronics. So there are a lot of electronics. I can show you the camera. So this is the camera. So it has got electronics, and there is also a lot of sample handling equipment. All these things are electronics, so they don't have to get corrupted, or they don't have to get spoiled. So they are protecting it with the kind of shield, a heavy metal shield. So this is the antenna. So this is the antenna that sends information to the Earth, high gain antenna. All these things are there. So we have to protect that. So that's why they have this kind of gold color plating. It's not gold plating, it's an alloy. It's a composite alloy.
Sir,
Yes, sir.
in the rover there is something called media.
Okay.
I want to know what is a media, sir.
Media.
Yeah.
MEDA. You want to know what is MEDA?
Yeah.
It's a kind of weather station. It is trying to find the atmospheric pressure, temperature, and humidity. So it is trying to find what is there happening in as a climate there in Mars. I'm going to explain it to you one by one. What are all these equipment in the next.
Okay.
So I will also show you another thing. Am I audible?